of our comprehensive course. Hello and welcome to chapter 9 of our comprehensive course on artificial intelligence, machine learning and data science. This is chapter 9 and here the name of the chapter is Exploratory Data Analysis. In previous chapter also I had shown this data science life cycle, that this is what our entire course covers. And if you know this, then you will become a full stack data scientist. But how much we have already covered in this course? Then we have done this much, and that some client comes with his problem. We took the example that a client with his business being marketed by 4 channels: social media, radio, TV and newspaper, and he comes to you and says that if I want to increase my sales, keeping my marketing budget same, how should I reallocate my marketing budget to different channels, and which reallocation will give me the most optimal sales or profit? Maybe you have to understand his business and convert his business problem into a data science problem. That is, make a model in which sales is the response variable and social media marketing expense is first feature, TV marketing expense is second feature, radio marketing expense is third feature, and the newspaper marketing expense is fourth feature. And then you have to make a mathematical function which relates your response variable sales with these 4 feature variables. That function is itself called a model. Then you don't have to get that mathematical function by using mathematics, but you have to get that model based on studying the past data of which your client has provided. So next step would be acquiring that data. The client may say that I have my data scattered across various databases. Then you have to get that data from SQL database or MongoDB, whatever. Or you may have to get it from API, or you may have to get it using scraping from internet. So different methods of getting data that we have seen, that how pandas can be used to read and load CSV file, TSV file, then Excel file, files directly from the internet, many other things. Next stage which comes is this: exploratory data analysis, feature engineering, data visualization. Now these 3 are so closely interwound with each other that whenever we want to discuss these, that is what we are discussing at present. So whenever we want to discuss these, then any attempt to divide this into different chapters is always going to be an artificial division, because the whole topic is in continuity and it is iterative. While describing an EDA, I have to discuss visualization. While discussing visualization, I have to discuss EDA. While discussing feature engineering, one has to come back to data understanding and EDA. Feature engineering also is helped by visualization. And finally, when you prepare the dashboard for your client does only this much, provides data and what is his dashboard, that's all. Okay, so then when you prepare the dashboard for your client, at that time also these stages will come into picture. What I am saying is that the next few chapters, they are division which I have made for the convenience and better comprehension of learner, but all these are related with each other. For example, if you see chapter 9, then this is chapter 10, exploratory data analysis 1, exploratory data analysis 2, then maybe this is 11, advanced pandas operation. So actually we have done 2 chapters on NumPy and 3 chapters on pandas, and still some more pandas operations were required. But before that it was required to do some discussion about exploratory data analysis. So that's why these 2 chapters are here. Okay, now then next is this data cleaning and preparation. But before doing exploratory data analysis in this chapter itself, I will show you that data cleaning and preparation is needed before doing EDA. So now that means these topics may come in slightly random order, and sometimes the topics may be repeated also, but be sure that you are doing things in very thorough manner, because this is the heart of data science. Actually, the real job of data scientist is this. This is the job of data engineer. This is also the job of data scientist, identifying problem and business understanding, but this is the job of data engineer. Then this model deployment, etc., also is the job of data engineer. It is a different thing that nowadays everything is expected from a single person only, and that is what a full stack data scientist does, and that is what this course aims to make you. Okay, so it's an ambitious course, and hopefully I will succeed. Now then the next chapter is data visualization, but you will see that in this chapter which we are now going to do, there only visualization is already started. Okay, next chapter is advanced visualization, next chapter is Seaborn, other library. Previous were Matplotlib library. Now Seaborn, still more visualization. This is advanced Seaborn, still more visualization, and still more visualization. So you can understand that all these chapters up to 17, I have clearly written here that 9 to 17 all are as such part of exploratory data analysis in some way or another. So the division into separate chapters is somewhat artificial, but for just for the sake of better comprehension of learner, we are doing it. And keep this diagram in mind so that you always throughout the course remain in control that where you are at present in the data science life cycle. So we have learned up to this, and now we are discussing this part. Okay. Now exploratory data analysis is critical step in data science process. It is aimed at understanding and the underlying patterns. So client has provided you fast data. You are not supposed to use mathematics to get the mathematical model, but from the data you will find some patterns. You means computer will find some patterns, and then spot some anomalies, check the assumptions, test hypothesis. I told in that client coming with 4 heads of marketing channel that the basic hypothesis first will be that my sales is being affected by changing marketing budget. That is first thing which we will validate. Then we will validate that for each marketing budget. Okay, my total sales is affected by total marketing budget, but is my sale affected by TV marketing budget? Is my sale affected by newspaper marketing budget? So we will test all this by hypothesis. Okay, and we will make a summary statistic of clients' past data, and we will try to represent the data into graphical manner. So EDA includes all this: getting summary statistics, drawing graphs or plots, trying to find some underlying patterns, spotting anomalies. For example, if outliers are there, checking the assumptions. For example, many algorithms like the linear regression, they require certain assumptions to be obeyed. So we will check before using linear regression that are these assumptions correctly satisfied? Because if the assumptions themselves are not being satisfied, then you cannot use linear regression, right? So all this is done in exploratory data analysis. And as I said, this is a very, very detailed discussion extending over several different chapters. So don't worry if you don't follow everything in first game. As such, it is fine. Nothing difficult is there. So now, what is the importance of data science, EDA in data science? It is importance in understanding the properties of data, identifying patterns, detecting outliers, and gaining insights. Now, that is what is very important, because client gives the raw data and he expects direct recommendations. That okay, you just recommend that reduce my newspaper marketing budget by 10% and allocate that to social media marketing budget. And once he follows your recommendation, he just expects that his sales should increase by certain amount. Okay, he does not care about what you are doing in between to generate that insight. He is just interested in gaining that insight. Then EDA also helps feature selection and engineering. In fact, as I said, some people call this feature engineering, etc., part of data pre-processing, another stage. But many people just consider this whole thing as a large exploratory data analysis. Okay, so then feature selection, which features are to be selected, which features are to be avoided, and engineering. For example, if patient's data is there and 2 columns are weight and height, then data scientists may decide that all the information of weight and height is included, already covered, if I just keep a single feature, that is BMI, because it is weight divided by height square. So then you can remove weight and height column and you can include only the BMI column. Okay, identify the relation between variables. Okay, for example, if there are correlations, then we have seen in previous chapter that if 2 variables are highly correlated, then we can remove one of them and still our model's accuracy, etc., will not be much affected. Okay, then informing the appropriate model choice. Now this stage is the precursor of this stage, this pink stage, model creation. So obviously for creating model, first you have to decide one algorithm, and there are so many algorithms that it is really confusing whether to use linear regression, logistic regression, clustering, whether to use SVM, random forest, XGBoost, whether to use neural networks, and so many different algorithms. So appropriate algorithm or model choice is also becoming clear after you do this, that you will start getting idea that this data is such that linear regression will work for this or linear will not work for this, like that. Then addressing the challenges which are posed by skewness and anomalies. We have seen what is skew and anomaly. Anomaly means mostly like outlier or something, and how to handle them in previous chapter, and we are again going to see same thing in this chapter. Okay, let us take one very simple example, just very simple example. Then the real interesting example we will take from here. This is exactly the example as you will encounter in industry as a data scientist. But before that, let us start with simple things. So understanding the distribution and summary statistics. So let us create one simple data frame with only one column. So in my dictionary, I am just writing the only one key, and the value is also just one line of code. Okay, so that means this data frame will be one column age, and that age column will be filled with np dot random dot normal. Now that means it will be random variable, but it will not be int, but it will be some fractions or floating point numbers. They will be distributed in such a manner that if I plot a graph passing through them, then that will be like a bell curve. So it is a normal distribution. This will become the mean, and this will become the standard deviation of the normal distribution. So here the terminology are different, but you will see that. And the size of that column is 200. So there will be total 200 observations. So we create a data frame using that dictionary, a very simple dictionary, and we will print that data frame here. So you can get one this kind of data frame of age. Okay. Now thereafter it is okay that you can round off the age, that 57.6 can be written as 58 and something that way. But this is how it should be. Now summary statistics we want to get for this age column. Which type of column it is? First, if you see this, then for that I can write one extra cell, and you can write df dot d type. Sorry. So only a single age is there, and it is a floating point. So whenever there is a numeric variable, then the summary statistic is obtained by one simple line that we have learned in previous chapter. That is that describe line. This dot describe. So df age dot describe. You can just write df dot describe also, and it will also give the same thing, because if there are multiple columns, then df dot describe will give the statistic for all the columns. But if there is only one column, then I can write df age dot describe. Both are one and the same thing. Okay. In fact, this appearance wise is better. Then you can see that count is 200, means that there are 200 rows. Mean is 40. That is what we had decided here. LOC 40. So I want to create a normal distribution with mean 40. Standard deviation 10.23. So standard deviation is 10. Okay. So then minimum value is this much, maximum value is 25 percentile, 50 percentile, 75 percentile, and maximum value is this much. Fine. And this is same summary statistic printed by using a print statement. Most of the time we don't bother to do all this, because when we learn the whole chapter, you will realize that this part actually data scientist does in his own private corner. I mean, these things are not to be shown to the client, but he has to pass through all these stages. So he does not have to report this thing to the client, and therefore he does not bother to write print summary, statistics, etc. He just write df dot describe. That's all. Now visualization. Now for visualization, the steps are very standard. These are the steps. Okay. Decide the figure size, for which I will use matplotlib library, and we will use import matplotlib.pyplot as plt, and thereafter plt.fig size. That will decide the figure size. Okay. Then plt.figure, and inside fig size variable, that will decide the figure size. Next, decide which plot you want to plot. Now for a single variable, there is hardly much to choose. You can plot either a box plot or a histogram. So here we will plot both. Then decide the title of this will be plotted by plt.histplot or plt.boxplot, depending upon what you want to plot. Okay, fine. Decide the plot title, for which I will use plt.title, and then whatever title I want to give, that in bracket. Decide x-axis label. So that is plt.x label, x label, and plt.y label. Okay. Then decide if you want to show the grid. This is optional case, but if some graphs look better if that graph like vertical and horizontal squares are there, grid is there. And then finally show the plot. So that is plt.show. If I now write the code, then everything becomes clear. First I am deciding the figure size. So of course, what is plt? That I have to explain. So import matplotlib.pyplot as plt. So ideally this command should be read like this: matplotlib.pyplot.figure, matplotlib.pyplot.subplot, matplotlib.pyplot.title, matplotlib.pyplot.subplot, matplotlib.pyplot.show. But now it looks very lengthy to speak that whole thing every time. So we create an alias. So this is nothing but an alias, that import matplotlib.pyplot as PLT. So as PLT means now onwards I can call it PLT. You can write X, Y, anything, but now all over world scientists have decided, data scientists have decided that we'll use PLT. So please use PLT. And this Seaborn, this is another plotting library which is slightly more advanced than matplotlib. So here we are importing both. The reason is becoming clear in one of the line. Matplotlib has one limitation, that it cannot plot what we call kernel density plot. But Seaborn can plot kernel density plot in histogram itself or separately also. What is the meaning? Let us see. So first decide figure size. Go by these steps, then everything becomes clear. So plt.figure and fig size, which is the variable, decide this many, this much should be the width and this much should be the height. Then these lines I will explain later on, these two subplot line. Okay. Then sns.hisplot. I am not using plt.hisplot. Otherwise, Matplotlib library, this can also plot histogram. But I am using sns.hisplot because I want to plot this kernel density estimation. That shows the shape of the data distribution, that how close it is to the bell curve or the Gaussian distribution. Okay. Then plt.title, okay, histogram of age. Again, this line I am skipping at present, but then sns.boxplot for age. Just like sns.histplot, df age, similarly sns.boxplot, x is equal to df age. Here, in this histplot, I have explained the meaning of kd is equal to true. It shows the curve, whether it is matching the bell curve or not. And these bins, that will show the number of histograms or number of vertical bars in the histogram. Okay. Here boxplot does not have any other argument. It just have one argument, which variable or which column you want to use for plotting the box plot. And then plt.title box plot of it. This is just like this plt.title. So these are the steps. Very easy. plt.figure. Okay. Then fig size is the variable. plt.boxplot or plt.histplot. That will be the plot type. So that is this. SNS, of course, we are using, we can also use PLT, but we are using SNS, the reason I already told you. So SNS.boxplot or SNS.hisplot, that you have to decide plot type. Decide plot title, then plt.title is equal to, this is histogram of age variable. And similarly here plt.title is equal to boxplot of age variable. Decide X label and Y label if you want. Here you are not deciding X and Y label, so fine. So it is optional. And decide if you want to show the grid. So here nothing about that is also written. So that means we will not show the grid. And finally show the plot. So plt.show. Let us and which data frame we are using? The data frame which we have created just now. That is this data frame, age data frame. Okay. So it has only one column, and we are trying to plot histogram of age data frame, and we are trying to plot box plot of age data frame. For plotting both, we are not using Matplotlib, but we are using Seaborn because it is slightly more advanced. Histogram comes out to be like this. The bins are this number of these vertical bars. If you count them, they will be 20, because here I have said bins is equal to 20. KDE is equal to true. That is this particular curve, bell curve. Okay. So this bell curve, that means KDE is equal to true. Okay. And DFH, that, and the title is histogram of age. Similarly, next is box plot of age. Now this, what about this? plt.subplot. If you don't write any subplot, then also your plots will be plotted, but they will be plotted slightly one after another. So if I plot, you can get this kind of plot, which is, or one over another, you can say. Or you have to then take these two, other histogram you keep in one only, and this box plot you take in other cell, maybe like this. What I'm saying is that if you don't want overlapping to other, so then the box plot will be plotted separately. And here this histogram, I am commenting out, suppose that line. So now only, box plot I am commenting out, so only histogram will be plotted. So if I don't draw that line, or don't keep that subplot, etc., then also it is fine. I will get each plot one by one. And in a Jupyter notebook, that does not make any difference. But it just makes one scroll a lot. And if it is a large data set with several variables, then it is a slightly tedious thing. So we do this. Now what this subplot will do, as the name itself indicates, it will divide the whole area, this fixed size 10 by 5 which you have written, into two parts. The first one shows the number of rows, in which row the next plot, whatever is coming, that will be put, and in which column it will be put. Okay. So it will be put in first row and second column. Okay. And not first row and second column, rather. I think it is, yes, this is the syntax. plt.subplot n rows, n columns, and index. Now what does that mean? Not first row, but total how many rows will be plotted. So only one row will be plotted. Total how many columns will be plotted. So two columns will be plotted. And among that one row and two column, what will be the index of this plot which is being plotted immediately in X? Then it will be the very first plot. And here what will be the index of box plot? Then it is also in same one row and two column that same format, but its index is 2. So that means that will be plotted after or on the right side of this histogram. And let us see, yes. So we are getting this kind of situation. Now I think you are understanding how many rows. So this is whole one row of plot. How many columns of plot? Then this is one column and two columns of plot. And in which this is how much index. Histogram is what index? Histogram is first plot, and box plot is what index? Box plot is second plot. Okay. So this is univariate analysis has two main plots. In addition, there can be something called violin plot also, but we are going to see that later on. Now, this I have shown that you can also plot them separately, so that is fine. Now, this is about graphical summary. But what about if you want to get its statistical summary? Then for which you have to use describe. So I can get that mean age is 40, standard deviation is 10, minimum age of my data is sample is 14 years, 25 percentile is here, and so on. So I can get numerical summary, statistical summary of my variable, and I can also get the distribution. This KDE plot is particularly interesting because it shows how far away your data distribution is from ideal or perfect bell curve. Now this you can see that age is distributed more or less like bell curve. So I can say that it is good enough to use the assumption that the data is normal. Okay. Then this part we have done, this also we have done. Now in next lecture we will do this, because this was a very elementary example, but most of the real data sets will not have just one variable. We created this data set with one variable. So most of the real data sets will have several variables, and they will in that how to actually do the univariate analysis, how it is actually done in industry, that will become clear from this example. So we will first create a data frame, artificial synthetic data. We will save that data in a CSV file. Next time we will read that CSV file, and we will try to clean it first, and then we will do a very detailed univariate analysis. And don't miss this chapter, because this you have to do practically in each and every, not practically, but always, each and every project of data science and machine learning. You have to do this univariate analysis. Otherwise, you cannot even select which algorithm or which model will fit the data. Okay. So please don't miss that. We will see it in next lecture. Thank you.